In this example, we want to find the inverse of the function f of x equals x plus 5 over 2x minus 1. So we do this via our normal technique. We want to swap x and y, and then solve out for y to get the inverse function. When we do this, we get x equals y plus 5 over 2y minus 1, just swapping x and y. And now to solve out, we're going to cross multiply and then go isolate the y. So we'll get x times 2y minus 1 equals y plus 5. Distributing the x, 2xy minus x equals y plus 5. And now to solve for y, I'm going to move the y over to this side and the x to the other side. Giving me 2xy minus y equals x plus 5. I can now factor out a y from the left-hand side. Y times 2x minus 1 equals x plus 5. And then I can divide through by 2x minus 1 to get that my inverse function, which is y here, is going to be x plus 5 over 2x minus 1. Now, if you look in this case, this is actually the same as the function we started with. In this case, our function f was also x plus 5 over 2x minus 1. So what can we take from that? Well, first of all, yes, this is entirely possible for the inverse function to be the same as the function itself. It doesn't happen too often, but it is possible. But we know something about this. Right? We know that the graph of f inverse is the same as the graph of f reflected over the line y equals x. But since they're the same function, this tells me that the graph is actually symmetric across the line y equals x. And if we were to draw a picture, we have the line y equals x, and the graph looks something like this, which is symmetric across that line. In terms of the function itself, it actually turns out the fact that the coefficient of x here is 1 and this here is minus 1 is the reason why this actually works out algebraically. If you were intrigued as to why this was the case, this might be a thought that maybe pursuing more math classes or even a degree in math might be something that is for you, because that's the thing that math think about all the time. Why does this occur, and what are the reasons behind why these patterns come about and why these things work the way they do? That's how you find the inverse function. That's how you can sort of interpret the fact that the function is its own inverse in terms of graphically and algebraically as well.